Hello friends, this is Florence Noah Christian from K. Shroff College. Today's session is on Lagrange's interpolation formula. We'll be seeing how to apply Lagrange's interpolation formula. Let us consider an example of the number of mobile phone internet users in India. The data is given for the 3 years 2015, 17 and 19. If the question is find the number of mobile phone internet users for the year 2016 and 18, it would be easy for us to find for 2016 and 18 by applying Newton's interpolation formula. Now here the difference between the years which is given comes under equal intervals, that is the difference is 2 years, so h is 2. So for 2016, solution can be obtained by applying Newton's forward interpolation formula, and for 2018 we can apply Newton's backward interpolation formula. What if the data is given as for 2015, 17 and 18? Here you can see that the interval is unequal. We have 2015, 17, h is 2 here, and 2017 to 18 there is a gap of 1 year. So here the number of users are given, but the interval is unequal intervals. Now in such sort of questions, how and what is the method to solve the problem? Because Newton's cannot be applied here, because Newton's can be applied only for equal intervals. For such problems we have a solution, and we come up with Lagrange's interpolation formula. Lagrange's interpolation formula can be applied for equal intervals as well as unequal intervals. The formula for Lagrange's interpolation formula is given by y of x. X is again whatever is been asked to you in the question. The table values we have x0, x1, x2, x3 and so on, and with respect to x0 the function y of x is y0, y1, y2, y3 and so on. So your formula is, in the first term we multiply the entire term with y0, second term is multiplied with y1, third with y2 and so on up to yn terms. The first term, when the term which is multiplied with y0, x0 does not appear in the numerator, it is in the denominator, that is x minus x1, x minus x2, x minus x3 and so on up to x minus xn, and in the denominator you get x0 minus x1, x0 minus x2 and so on. In the second term which is multiplied with y1, x1 does not appear in the numerator, x1 is in the denominator, that is x minus x0, x minus x2 and so on, and in the denominator x1 minus x0, x1 minus x2 and so on. The formula continues till the number of terms which you are having in the table, and Lagrange's interpolation can be applied for both equal and unequal intervals. First note down all the values from the table, all x0, x1, x2, x3 values, y0, y1, y2, y3 values, and the value of x which will be given to us in the question. Write the formula of Lagrange's interpolation formula, substitute all the values and come to the solution. For example, making use of Lagrange's interpolation formula, find the value of y when the value of x is 8 for this table. In the table we can see the value of x as 5, 6 and 9. The value of y is 12, 13 and 14. Here we have unequal intervals, and when x is 8, what is the value of y? First we note down the table values x0, x1, x2, y0, y1, y2. Now here we have 3 values, hence your formula also will be having in Lagrange's theorem up to first term, second term and third term. That is first term multiplied with y0, second term multiplied with y1 and the third term multiplied with y2. After you complete writing the formula, we have all the values which are given to us in the table. and the value of x which is asked to us in the question, x is 8. And in the formula, the first term x0 is not there in the numerator, it is there in the denominator. x1 appears in denominator of the second term, it does not appear on the numerator. And in the third term, x2 does not appear in the numerator, it appears in the denominator. And then by substituting all the values, we come to the answer as y of 8 equals to 14. Similarly, Lagrange's interpolation formula, find the value of y when x is 3. Here you can see the value of x is 2, 4, 6. That is h is 2 here. This comes under equal intervals. So here we can apply Newton's also in order to solve, but here in the question it is specified using Lagrange's interpolation formula. So whenever it is specified, you are supposed to apply the same method. Otherwise, for this equal intervals, we can also apply Newton's formula. X is 3, hence we can apply Newton's forward interpolation formula. Now let us coming to Lagrange's interpolation formula. Again same, note down the values. Again we are having here 3 values, x0, x1, x2, y0, y1, y2. Write the formula of Lagrange's interpolation. We have Lagrange's 3 terms. So we get first term into y0, second term into y1, third term into y2. x0 comes in the denominator in the first term, x1 comes in the denominator of second term, and x2 comes in the denominator of the third term. And hence your value of y has to be obtained when x value is 3. So by substituting x equals to 3 and all the values from the table, we get y of 3 value as 8.375. Hope all of you have understood this session. Thank you.